Hello, this is Charlie Thompson, and I wanted to give you a quick overview of some satellite imagery so that you can enjoy it more. So this is what we're looking at right now. It's a 3-day loop, and it's visible imagery during the day, and it's infrared heat imagery at night. And I wanted to go over some of the large scale features, and then later in a minute we'll go over some of the small scale features. So I'm just going to stop it right there. The first thing that I wanted to point out is you can actually see the position of the sun. So right now you can see this line right here. That's called the terminator line. And over here it's daytime, and over here it's night. And the angle of the terminator line is a function of the seasons. So right now, the subsolar point is south of the equator. So the actual latitude that's getting sunlight hitting it at a 90-degree angle, it's right down in here. So if you live at this latitude, you would be getting sunlight hitting you at a 90-degree angle. And if I press play, you can actually see the sun shining off of the ocean. You can see the reflection work its way across the Pacific, and that's telling us the position of the sun. So that's part number one. Part number two, I already mentioned, and that was the angle of the terminator line. So again, here's the terminator line, and there's the sun. So the sun is hitting the Earth. Ooh, that's nasty. So the sun is, like I said, down here relative to the equator. The terminator line is at an angle because we haven't hit the equinox. On the equinox, and I'll show you this in just a minute, on the equinox you'll see that the terminator line will be vertical because the sun will be shining over the equator. And then 3 months later, in the summertime, you see that the terminator line is going to be like that because the sun will be up in the northern hemisphere. And I'll show you an example of that. So let's just hit play again. Couple other features in addition to the seasons. In fact, you can see right along here, there's a belt of clouds that every day get bigger and smaller, and you can see them better at night. At night, the white clouds are high altitude, so they're cold, and the blue clouds are lower in altitude, they're warmer, and those are made of water droplets. So the white are ice crystal clouds, and the blue are water droplets clouds. So this is the ITCZ, the Intertropical Convergence Zone. And if you live in the tropics, every day you're getting rain. So some other features, and if I zoom in, it's going to take forever, so I'll just pause the recording. Okay, so now I've zoomed in a bit, and I am finding myself hypnotized by these huge cumulonimbus thunderclouds along the equator. But that's not what I really wanted to zoom in and take a look at. So here we've got a big swirly area of low pressure and a smaller area of low pressure right behind it. We'll get into all this in chapter 3, but for now, I figure the more times you hear things, the better the chances that you remember it, the better the chances it makes sense. So low pressure in the northern hemisphere goes counterclockwise, and that's associated with storms. Out here in the Gulf of Alaska, we've got these two huge areas of low pressure. These are storms. These are the kinds of storms that bring us rain in the winter. You can see warm air coming up out of the tropics, and it's mixing with cold air, riding up on top of the cold air, and getting chilled and making clouds. So there's low pressure with clouds and storminess here, and high pressure. And this is part of the reason that I first started looking at this. I thought, wow, there's all this amazing high pressure. The winds are blowing from the north in the Sacramento Valley, and there's Santa Ana conditions in Southern California, so I'll bet there's high pressure. And indeed, you can see the clouds getting blown away from the coast. There's high pressure, which means that air is sinking, and as air sinks and spreads out, it rotates clockwise. So there's an area of high pressure in here, low pressure here, high pressure. Another obvious clue that there's high pressure is the lack of clouds. Low pressure associated with clouds, high pressure associated with clear, sunny skies. In fact, I don't want to zoom in right now because it'll trigger a refresh of everything, but you can see the fog slowly disappearing in the Central Valley. Bleep. I'll see if I can't stop it at a good frame. Yep, so the sun comes up, and now we've got fog in the Central Valley, and then it disappears. So another thing I wanted to point out, and you can see it better now, is if you were, well, let's just say right here in Alaska, I don't think it's ever getting sunny. Nope. So you can see it's dark during the night, but then even during the day when the sun comes up, it's not getting light because they're above the latitude that is getting sunlight for this part of the year. It's wintertime, and at the North Pole, during the winter, they have 24 hours of darkness. Okay, so let me zoom in one more time. There are some other really cool features, and let's see what happens. Okay, so I zoomed in a bit, and I just wanted to emphasize these huge swirling areas of low pressure. This stream of moisture out of the tropics, you can see like a fire hose. In fact, it was setting records for rain in Alaska, this sort of situation, although in this case, you can see this plume of moisture, in this case, getting directed up to Alaska and British Columbia, and then this next stream of moisture directed more at Washington. But these are the streams of moisture, sometimes called atmospheric rivers or the Pineapple Express, when these plumes of moisture come out of the tropics and absolutely drench the Pacific Northwest or California. Okay, so that's pretty good for the weather satellite for now. Let's take a look at some other geovisualization tools. Okay. This is Charlie Thompson, and we're back looking at more satellite imagery. This is satellite imagery from 2017, from July 9th. It's some archived imagery, and the reason I picked this data is because it was available, so that'll work. So I wanted to show you again, here is the angle of the terminator line. The sun, you can see the sun or the subsolar point right in at this latitude, so it's summertime in the northern hemisphere. And now, some of the other things you can see the shine of the sun move across at a much higher latitude instead of down here south of the equator. You can see the ITCZ is over the Amazon. That's why it's a tropical rainforest. It's because of the presence of the ITCZ throughout the year. You can see a hurricane out here in the Pacific, and some other cyclonic storms trying to develop. And finally, you can see there's 24 hours of light above the Arctic Circle. So if you're at the North Pole, and I'll hit play again, if you were at the North Pole, you can see you would have 24 hours of light. It would never get dark. So this is the summer pattern. The subsolar point is in the northern hemisphere. So the Tropic of Cancer is getting direct sunlight. That's why the Tropic of Cancer is so important. The Tropic of Cancer and the Tropic of Capricorn are the limits to direct sunlight. So just a quick refresher, ITCZ, the Intertropical Convergence Zone. We've got some sort of tropical storm trying to form out here in the Atlantic. We've got a hurricane rotating counterclockwise. Remember, low pressure rotates counterclockwise. High pressure rotates clockwise. So you can see there's some high pressure going on here. Low pressure here. And that's pretty good for now. Okay, one last view. This is about as good as I could get. This is as close to the equinox as I could hit. So this is September 11th, which, in another 10 days, it's going to be the equinox. But you can see now that the terminator line is closer to vertical, that the shine from the sun is much closer to the equator than it was before, either above or below the equator. And now, because it's September, the eastern Atlantic has been warming up all summer long, and now the water's really warm, so it evaporates, and as it evaporates, it condenses, and if conditions are right, it'll create hurricanes. And there's two hurricanes right now. There's a hurricane right here, and another hurricane right there. So as I hit play, you can see these huge swirling storm systems. There's one hurricane, there's another hurricane. You can see the ITCZ is shifted well north still. You can see daily rainfall over the Amazon rainforest, cumulonimbus thunderclouds, and in fact, you can actually pick out sometimes individual large, like right there, large thunderclouds forming over the ITCZ or under the ITCZ. All right, that was good. And let's move on.